Thank you, Mr. Upadhyay. So the first session after lunch, we have a distinguished speaker, Dr. Shivaraman Ramaswamy from Big Bang Boom Solutions Private Limited. The specialty about him is that he is one of the youngest PhDs in nanotech in the country. After doing his bachelor's in computer science and master's in nanotechnology, he had a wide range of experience across Western Australia, University of Western Australia, Carnegie Mellon University, SRM University, and Baba Atomic Research Center. He has published more than 50 research papers and 2 patents. He started his entrepreneurial journey with Accenture, a research incubation startup, and spearheaded the management consultancy, research incubation, and new product development verticals of Accenture. He has now co-founded Big Bang Boom Solutions along with Mr. Praveen Dwarakanath, an indigenous defense solution provider and a tech integrator. They are one of the top defense tech companies in the country. Big Bang Boom's flagship product is an indigenous counter-drone systems to detect and neutralize incoming UAS. As a researcher and passionate educationist, Dr. Shiva is adept at solution engineering and nurturing research potential across the country. Dr. Shiva now serves as an investor and advisor for several startups such as Empower Labs, Flick Sports, Who Food Innovations, and Portmanteau Food Solutions. Today, the topic Dr. Shivaraman will be delivering is Strategic Innovation, Exploring the Indispensable Role of Polymers in Advancing Defense Technologies. Welcome, Dr. Shivaraman.
Thank you, sir. I really thank you for this very warm welcome. And I really thank this entire organization of Plastoteck for inviting me here. I'm from Big Bang Boom Solutions. We are basically, as sir rightly said, we are a defense technology startup. Just a moment. So we've spent the last 5 years or so building indigenous technologies, primarily for defense applications. What I'll try and do and cover over the next 15-20 minutes of my time is to try and say how plastics has really affected or plays a big role in the defense ecosystem, not only in my company, but in the larger defense ecosystem. So India has actually moved forward from having what is known as technology transfers and being dependent on foreign countries for technology to having a very thriving ecosystem. I was at an event called Swalamban in Delhi. There are more than 1,200 startups that are developing products in India. And a lot of them are currently dependent on countries like Korea, China, and Taiwan for their manufacturing requirements, including our own. So if there is a way we can integrate whatever we are doing here with the defense ecosystem, I think there's a great synergy to be built here. A brief introduction on the company. We started off in 2018. We started off with wanting to build defense technologies in India. Our primary target was through what is known as the IDEX platform. Big Bang Boom today has over 8 projects that we have developed under the Innovation for Defense Excellence platform, including the anti-drone system, the see-through armor, etc. These are products that basically not only is able to detect drones that come in, but also upgrade tanks, like the tank factory in Avdi. We work with them on upgrading tanks. We also work on polymeric materials that can stop propellers or ships in the middle of the ocean. It's actually a nanotech-based polymer that we use for something like that. And a lot of these technologies are completely built and developed in India. Where is it? What are the fields in which we work on? We basically work on AI, material science, UAS, GCS technologies, etc. As you can see right at top, a big chunk of the R&D work that we do today is in material science. And that is basically where we look at the synergy with the plastics environment. Major applications. Why is it that defense is very interested? There are 2 major things in defense that we are very worried about when we build products. One is what is known as a SWaP-C constraint, saying that in defense, people always want small size, small weight, and durable solutions. And when you want to go for small size and small weight at the same time, then plastics becomes one of the most promising solutions that are there. Now, the criticality also comes in saying that we need to adhere to what is known as GSS, the General Services Specification. These are ruggedization norms by which, let's say, a product that you build for defense needs to be waterproof, it needs to be sand-proof, it needs to be corrosive-proof, it needs to be lightweight, all at the same time. And internationally, if you see, plastics have done the job really, really well. There are these specialty polymers that are available, especially fiber-reinforced plastics that have been able to be as good as aluminum or even sometimes better. Unfortunately, we don't have an ecosystem, so companies like us, for even something as simple as transport cases, we are dependent on foreign countries. We buy the transport cases in which we transport our equipments from foreign countries. There are Indian vendors that have now started coming up, but the quality is very, very different. So given the potential that is there, the lightweightity and the durability, it makes a lot of sense for us to start investing or start developing these ecosystems, because India is very clear. As a country, the government has banned all defense imports, which means that every defense product going forward in the country will be manufactured by India. If it has to be manufactured by India, currently, whatever is trivial or whatever is more non-tech based is currently getting outsourced because nobody cares about it. But if the ecosystem can absorb it, nothing like it. What we work on, in Big Bang Boom, one of the applications that we work on is radar absorbing materials. This is a big thing, primarily because the radar absorbing materials is basically a very thin plastic or a polymer coating that we usually apply. This is applied on top of tanks, it's applied on top of ships and on top of aeroplanes. This is usually done to reduce the radar cross-section. How is the radar cross-section reduced? It's usually done by being able to get a polymer film with material, with properties that can reflect the radio waves from a radar. This is simple polymer engineering. I'm sure there are enough people here who will be able to do something like that. We pay millions of dollars every year for this quality of paint. It usually comes to us from Russia. Slowly we have started importing it from Germany. It's as simple as paint. Like if you see, this is a special grade paint that comes from there. And frankly, we are not able to get something like that in India. So not only will Big Bang Boom be able to use it, but the entire ecosystem, literally any equipment that I supply, I don't want it to have any radar signature, especially if they're big equipments, right? Apart from this, there's a lot of polymer, and this is something that we are very conscious on, where we look at polymers for both electric insulation and electric conductivity. So we make these a product known as the see-through armor, where we make these day and night cameras. The main thing in this is that the camera needs to go through what is known as EMI EMC clearance. It needs to be shielded from all kinds of electromagnetic interferences and electromagnetic conductivity. There are 8 tests specified where it is subjected to various electric fields, and they measure whether by installing this system will it interfere with any other system in the vicinity. One of the best solutions we have been able to find is to be able to coat the entire thing with a conformal plastic polymer-based coating that will completely insulate it from anything else there. So each wire doesn't touch any other wire, and the entire thing automatically becomes dust-proof and waterproof. At the same time, plastics can also be used, especially plastics such as polyacetylene and anilines. They can be used as a conductor. So places where you don't want a metal-based conductor, there are intrinsically conducting polymers that can be utilized. If the availability of this becomes better in the country, then there is nothing like it. Like one of the very, very nice examples that we were recently in Israel that we found out is that in Israel, in defense technologies, they use basically a liquid that becomes a polymer when a little bit of force is applied to it. So it's like literally like a drop of liquid that they put it into a screw hole before they screw the screw in. The advantage is the minute they start screwing the screw, that becomes into a solid, and that actually holds the screw and the head together, thereby preventing it from getting unlocked when it's there. It's a it looks like a very simple product. Unfortunately, something like this is not available in India. Because it's not available in India, we are either dependent on them to provide that polymer to us, or we have to go forward without using it in our equipment, which makes it significantly poorer in quality. Apart from this, adhesives, coatings, and one of the key areas in which I see a lot of potential for people from this industry to work on is ballistic protection. The body armor field has not really improved anything in the last two decades or so. We used to have Kevlar, and after Kevlar, we used to have high-density polyurethane-based body armor materials. This has been consistently the same for the last 20 years or so. I think there are few industries, such as SMPP and I think Buchanwala in Pune, who have started working on more ceramic materials that are there. But around the world, excuse me, around the world, a combination of fiber reinforced plastics are still considered the best for bulletproof protection. Currently, if you look at it, India's bulletproof needs are met by material that's coming out of China. Okay. Given that we have such a big industry, and as a company, we actually have built some of these polymers ourselves. We obviously don't have any manufacturing expertise or capability, so we have never been able to take it forward. So if we can work with somebody, we can always look at creating good bulletproof armor. The point is, the once you're able to build a bulletproof armor, not only can be used for personal protection, it can be used for police forces, it can be used for vehicle protection, so on and so forth. Apart from this, there is also polymers that are actively used in other defense applications like chemical and biological defenses. So one of the most common examples of this is the hazmat suit. Again, something that there is a company led by Major Anup Mishra that has been trying to build an indigenous hazmat suit for the last, I think, 8 years now, and they're still not successful. The entire technology has to do with, having polymer-based materials that are impervious to any chemical agents, any biological agents, etc., and to be able to provide clean air to the force engager or the police officer or the armed force guys who's wearing it. If you think about it, it's a very simplistic solution, but each hazmat suit currently sells for more than $20,000. That is, we are talking about lakhs of rupees for a single suit that we buy. And India has to buy it. I mean, as a country, we don't have a choice. So this is again something that we are very interested in. We have been looking out for partners, trying to see if there is somebody who can engage with us on it. Okay, there are ways in which we can take care of the air filtration part, we can take care of the processing part of it. But the core plastics or the polymer itself is something that's beyond our company's capabilities to work on. Apart from this, there's also a lot of miniaturized applications, like there are enzyme-based photoluminescent processes that are there. This is basically used for detectors. So a variety of detectors have now started coming around the world using polymer as the primary agent. So what these polymers usually form the bed in which the chemical gets absorbed, and by measuring the resistance or the conductivity of the polymer, you're able to say if there is a biological agent in the region or if there is a chemical agent in the region. The advantage of using polymers to other materials is that usually when you use a non-polymer based materials, they are also bioactive in nature. So they have a shelf life associated with it. So the new age polymer based detectors that have come up actually have a very, very long shelf life. Like they can be used for multiple years at a stretch. So from the end user's point of view, it is a huge advantage. But again, we come back to a point saying that we don't get into this kind of deep tech technologies as of today, as we understand it. Where do we see the future? What are the places where industries such as defense would be interested in collaborating? The biggest industry today is drones. If you look at the Indian defense ecosystem, more than 50% of the requirements currently is in unmanned aerial systems. Drones are of multiple form factors. You have small drones, what are known as nano drones. There are mini drones, micro drones, large drones, and then large UAV systems. All of them, without a doubt, all of them use 80% of whatever their BOM is, the bill of materials is based on plastic. Whether it is their motor encasings, their airframe, which is a major thing, the enclosures for their battery, the mount on which they, the processors and the autonomous systems sit, all of that need to be made out of plastic, because any other material, then the weight becomes too heavy for it to fly and to give a proper endurance for it. Currently, these are being done in an ad hoc fashion. Like there may be a few collaborators here who are already there in the drone space. Okay. But the problem is that, or the challenge is that given the drone market, like for example, even for in our case, when we want to build a single prototype, we find it very hard to find a vendor or a partner who's willing to work with us on it. In large scale production, there's no problem. We can create a mold. There are enough people who are able to do that. But the ecosystem, for us to be able to become vibrant in the defense ecosystem, we need to be able to make those single prototypes. And for making those single prototypes, we are still dependent on foreign countries. The only alternative that we have is 3D printing in India. The problem with 3D printing is that it's not similar to, a molded product. So when I do, let's say I build a prototype out of 3D printed plastic, I do the testing. I cannot be sure this is the same performance I will get when I do the bulk production. And that becomes a big variability. A lot of times we have done 3D printing of our own drones, and usually the printing is not good enough. It's very brittle, it breaks very easily. So if there is a way where, as an industry, we can set up like a prototyping center, a rapid prototyping center, we can start accessing a lot more of the other industry needs that are there. The second thing is enclosures. Enclosures are basically the body of a product. So like, for example, if everybody is, we have these RF jamming guns that we are currently supplying to the Indian Air Force and the Indian Army. These basically have a power amplifier and exciter. We use it to take down drones. We've recently got 6 orders in this category. The power amplifiers, we are getting the boards from Israel. The silicon comes from Israel. We do the population here. We are able to build the electronics in our own lab. But the enclosures, the kind of quality of enclosures that we require, and given that the orders are very few, like I've got 6 pieces in a 3-month window. So it's not like I can make 100 pieces or 200 pieces. It's a very expensive thing, but then the volumes are very low. So currently I'm getting them made out of a factory in Taiwan. So the guy actually sends the enclosures from there. We do the assembly here before we ship it out. So if there is a way, not only in my product, this is a thing that is faced by almost everybody in the same industry. So if we can start doing custom enclosures, and especially custom enclosures in high quality plastic that can meet the ruggedization needs, I think it's a big industry that's waiting to be captured. One other thing is the exoskeleton. Exoskeleton is a very new field where they are looking at a suit that can be used to enhance physical abilities. We look at people being able to carry heavier weight, walking through tough terrains, etc. The critical aspect of the exoskeleton is that given that it is supposed to help you navigate, the suit itself cannot be very heavy. So we have done this in both in aluminum and in GI-based materials, and it's frankly too heavy. The suit itself is around, I think around 28 kgs or so. So if there is a way, we don't understand the technology, but if there is a way where we can start working with plastics on something like that, I think that will be a great place to work on. And as I mentioned earlier, basically the packaging materials, the packaging boxes in which we transport cameras, you transport gums. This is a huge field, and typically there is a specification for it. We'll be happy to give it to you. It's JSS 1059 or something similar like that. There's a particular specification that government has given, and there are only 3 or 4 companies in the country that's doing it. 3 of them are doing imported products. There's probably 1 guy who's manufacturing in India and supplying to us. Okay, and this is a huge requirement. Like everybody, starting from the DPSU to the small industry, will be looking at these kind of transport cases as we talk about. So overall, while there is a lot of opportunities, there are also a lot of challenges. I, as an industrial person, I also understand that there is a cost associated with it. And there is also security concerns that we need to be very careful about. Primarily especially when we are looking at naval applications. So the Navy is very, very touchy. They are very keen to ensure that none of the plastics or the polymers that they use are toxic in nature, because they are exposed to a lot to the ocean waters. These are eccentricities, or these are idiosyncrasies that we will understand as and when we get into the particular this thing. What we can do, or what we try and do, we try and work with both universities as well as research institutions. We try to partner. There's also another way where some of these complicated or some of these tough challenges that I'm talking about, if there is not something that's immediately available, we can look at working with the IITs to try and develop that's customized. We do that a lot in defense. Let's say, for example, there's something that we don't completely understand. We try and give it as a research project to the industry and try to pick up that particular technology. Overall, where we stand today, we look at polymers and plastics playing a huge role in the defense industry. We would love to work with the team here. We'd love to see if there are people who are willing to collaborate with us. A brief, as I told you about the company. In our company, that's the jammer gun I was talking to you about earlier. You can see there on the screen there, a good gentleman holding it. That's the jammer gun that we use. We also make these interceptor drones. These are kamikaze drones that get destroyed when they are deployed. So this is something that's a recurring requirement for us. The products that we talk about are very well recognized. So if we start getting into these fields, not only will we be able to serve the nation, but we'll also get recognition from the top people in the country. Happy to answer any specific questions, and I'll also hang around here if there are any person who want to instruct of that. Thank you.